So I'll pass the word directly to Fraser Lewis, who is the next chair. Fraser, are you there, alive and kicking?
I am. There's nothing like knowing that that's going to happen, though, is there? So thanks to Gustavo and Rosa for keeping that a secret. Right. Okay, good. No, I know you do this. I know you have fun with me to make sure I'm just paying attention. So if I understand then, we're going to run straight into a set of 5 20-minute talks. And the first of those coming up right now is Mila Mitra, and they'll be talking to us today about virtual space summer camps in the time of pandemic. So I can see we have video. Mila, are you able to share your screen and check your microphone works okay?
Yeah.
Don't hear
you can see the video. I mean, you can see the presentation.
I think it's just loading now. It's just, there we go. Yeah, see a presentation, we can hear you. So yeah, we're good to go. You've got 20 minutes. I will probably jump in after about 18 because I know Gustavo will be jumping up and down to make sure you finish within the 20. But for the next 18, 20 minutes or so, the floor is yours. Thank you.
Hello, everyone. And thank you to all of you at Global Hands-On Universe for giving me this opportunity to interact with people from all over the world that are interested in STEM and how to take STEM forward in education and in the community. So again, my name is Mila Mitra, and I'm the co-founder of an organization called STEM and Space based in India. So we just heard this wonderful talk by Scott on all kinds of aspects of space education in times of pandemic and what they faced. And I'm going to talk about one single concept, which is summer camps. So just to give you an introduction or a background of where space education is in India. I know there are a lot of participants here from India, so I guess they'll all have different things to add to this. So STEM or STEAM. So the way it works in India is education is important, but it's deemed to be primarily important to get good jobs and not just for the sake of learning or curiosity or finding out more about the world. So the topics that are popular in STEM are the ones that are job oriented, such as engineering, for example. So, but what our objective is to take STEM forward to promote rational thinking and a scientific temperament. And also, as all of us at this conference know, that STEM is going to be the way forward. All kinds of jobs are going to be popping up in STEM, not only in space exploration, but in computers and biotechnology, artificial intelligence, and so on. So we want to expose students to these different kinds of careers and encourage them to follow these footsteps so that they get there when they are adults. So the current scenario in India is that there's no astronomy at the school level. It's present only at the university or the college level. However, again, like Scott said, and some of us are doing this in India, we can take it forward to schools or to the community as activities or extracurricular. And recently, the government has introduced astronomy labs and Tinker labs, which are robotics based. So that is promising. Okay, so why should we use space to teach STEM? Because it's all around us. We observe it everywhere, all the way from sunsets, seasons, changes of the moon phases. It's through astronomy and space, and that is our prime concept too, that through this, you can tackle all kinds of different science, technology subjects, all the way from physics, math, engineering, computing, geography, climate. So not only subjects, but different skills. It's very easy to make it hands-on and interactive. And of course, by definition, we have astronomy and space involve the outdoors because you can do field trips, observing. So, and what we've seen are that laymen and amateur astronomers, they're very interested in space as a topic. So it's very easy to pull in students and attract them to this topic. STEM and Space is an educational organization, and we try to teach STEM through using the domain of space science and astronomy. So we want to create the future ready generation, and everything we do is STEM based experiential learning. Okay, so our approach is everything is hands-on and experiential. So we don't just give presentations, but every session we do, we try to make the students do something so that they learn while doing. Investigative learning. We bring in projects and international programs, some of which have been mentioned, like Global Astronomy Month, Asteroid Search, IASC, Asteroid Search Campaign, World Space Week, and such programs. We promote outreach. Whenever there are celestial events, we bring students and the public to try to observe it and get the excitement out of observing celestial events. So we have different kind of products. We have the clubs that run all year, and the clubs start with a basic curriculum and expand slowly to more and more advanced curriculum. We have workshops that are one time and one topic, summer camps that are 5-day with 5 different topics, and like I said, projects and international programs. So today I'm going to be talking about summer camps and why that was important in the time of pandemic. So let me describe what I mean by summer camps. These are 5-day camps. Each day we target one different STEM topic. So 5-day, 5 topics. We get a glimpse into STEM careers. And here I would like to point out the giant moon map. Scott mentioned from the Aldrin Foundation, the giant Mars map. And I'm proud to share that we, STEM at Space, are also recipients of the giant moon map and the giant Mars map. And these are wonderful tools because students can walk around and explore the surface of the moon or Mars and learn about different things like features and landing sites and so on. Coming back to summer camps, every session we do has hands-on activities and it's interactive and fun. And you get to work in groups. So again, hands-on, investigative learning, and we target to build different kinds of skills such as engineering, making models, experiments, graphing and plotting, computing, and of course, art and crafts. And we go through the whole age group all the way from grade 2 to grade 10. So yes, again, astronomy can lead to all kinds of topics, and these are some of the topics that we try to highlight. Climate, of course, is very important now because of the IPCC, and we try to bring some project of climate to every session. Earth science, satellites, gravity, light, and so on. So what happened during the pandemic? Just like in other countries, there was a total lockdown, no schools. And in fact, schools haven't opened in India till now, except for very few situations. So all education had to resort to online and virtual education. So this brings us to the problem. How do you do any of these things we've been doing virtually? So we had to face these issues, no physical locations. How do you create these activities I'm talking about and give out the material? How to keep the students following the educator and keep them engaged? And how do you do group interactions? So of all the products that I mentioned that STEM and Space are doing, summer camps seemed like one of the best choices for engagement. These are 5 days, so no long-term commitment. Students can just come and sample it. It's like a sample or a taster. So because we have 5 different topics, it's a variety of topics. It's at the introductory level, so it can be fun and students can figure out which topic they're enjoying, such as satellites or rocketry, and they can further take lessons or read up more about those topics. Again, it's hands-on, so you can keep students engaged. They don't just have to watch you, they'll be doing something with you. So how did we find some of these solutions? So yes, we decided to go with summer camps as the engagement. Since schools are closed, we could not do clubs or physical workshops anyway. So we decided to design simple activities where students could follow the educator online. And we could no longer, India had total lockdown, so we could not even for a while send out couriers or kits by mail. So we redesigned our activities so that students could download and print, or make it, or buy easily available stuff or things from your own house. We gave them revision videos so they could follow along. If they couldn't do it as fast as us, they could still repeat it at their own homes. We pulled in many online engagement tools such as games, puzzles, and quizzes. And we tried to do limited class sizes so that we could actually interact with all of them and see what they were doing. So I'm going to give you a glimpse of this kind of sessions we did this year. Again, like I said, 5 topics. So for juniors, starting from grades 2 and 3, we rocks in space. So we even had fun names so that they enjoy and don't think it's too technical. So rocks in space, about comets and meteorites, water cycle, parachutes, binary, and space satellites. So for juniors, we try to do things that are arts and craft based, such as a picture you see here where students made their own asteroids and comets. And through making them, while making them, they learn the parts of the comets and asteroids and so on. We also try to make presentations for juniors story based, so that again, it doesn't seem too technical to them and they can get an idea, they enjoy. And we have some characters that are there in all the stories. So students start identifying with these characters and they can find out more about each topic. Here's an example talking about students going to a science museum and learning about comets and Halley's Comet. So yes, we have presentations like this that pull in kids through story-based concepts. Here's an easy way that we are doing computing without computing skills or the basics of computing without really programming. And this is the language of satellites or machinery. And to very junior students, we taught them what is binary and to make their own name bracelet in binary. It was a very fun activity. So for middle and seniors, we do more investigative learning where they're given a problem, they have to solve it with our help and reach a conclusion. They do experiments, make models, graphing and plotting, computing. And again, these are the skills, but we have all kinds of different topics that they learn about. Like I said, we're trying to bring in atmosphere and climate. So here we have for the middle grades, atmosphere, light and spectroscopy, celestial coordinates, our own Chandrayaan, which was the moon mission, and mapping volcanoes. So, and for seniors, we had life cycle of a star, and again, changing climate, which was rise in sea surface temperature, the James Webb Space Telescope, how to look at and interpret satellite images, and cosmic calendar. So just some examples of what I've been talking about, model making. We give them the printouts, and if they can make color printouts and good ones, then they get really nice models like this. Otherwise, we let them trace out and make their own models. This is an example of how we taught them how to interpret satellite images. On the left-hand side, as you know, satellite images come in numbers like raw counts, and we taught the students how to recolor these based on the numbers and which bin they fall into to get an idea of how scientists interpret the data or visualize the data. Graphing and plotting. Here's an example of celestial coordinates and how we give students certain stars that they could plot using the coordinates given and come up with a constellation or something like that. And they don't just plot it on their own graph paper, but we also allow them to annotate one by one on the educator's screen so that they come up with, so that each of them get a chance to interact or show how they are understanding it. So experiment base, uh, measuring rise of water level with melting glaciers. And on the left-hand side, we have mapping a volcano where they create a simple volcano with a baking soda and a bottle cap, and they do it repeatedly. And they try to put clay to measure how far it goes. And through this, they learn how you can tell the age by drilling in through different layers. So I've talked a lot about our summer camps. I'm going to show you a very short video about the way it played out and how the students enjoyed it. So yes, so we did do summer camps, and you got a glimpse of the kind of activities we did and how the students were enjoying it, and what were the advantages to doing it virtually. We could spread the virtual camp to any location. It was no longer bounded by physical distance, and we could reach even remote locations and all kinds of communities who were interested. And earlier, of course, it was based on being close to where we are located. So now it was also cost and logistics savings because our educators could do it from their own locations, and we didn't have to book centers to do this. So I want to show you how it grew in this virtual camp. We started out with 500 students, and in this year, we had more than 3,000 students. So the first year we started this camp in 2019, it was based mostly in the northern Indian region where we are. In 2020, it spread to all parts of India because last year it was already virtual. And then we further worked with this camp and spread the word. So in 2021, we were also able to go to UAE and other locations. So, like Scott said, and like Rosa said, the virtual community has been great. We can contact anybody, we can get any speakers, we can bring in all kinds of things. So just some tools that we use, of course, Zoom and YouTube, but also in astronomy and sky, we showed Stellarium, and we showed students how to use apps such as Sky Safari, Scratch for juniors, and Salsa J for seniors for some computing and data analysis. And we use Kahoot nearly in every session. Okay, so that's the conclusions. Space as a subject can be a great method of introducing STEM and creating scientific temperament. We find students and the community, even adults, are so interested in finding out what's happening in space and the world of space. During pandemic, we converted it to the online mode successfully, and these space camps proved to be engaging, although online. And the advantages were we saved in cost, logistics, and our reach was much higher. So going forward, a hybrid model may work great as the pandemic ends, but we can still reach out to much further and make it inclusive and target all kinds of communities. So with that, thank you everyone for joining me. I hope we can all collaborate more. I'm hearing so many different things, and I'd love to share our ideas and work with people in this conference to further our interest in space and space education. Thank you.
Mila, thank you so much for that. And you finished exactly on time, which means that I don't have to be the bad guy and jump in and ask you to stop when people are listening and enjoying what you're saying. And yeah, fascinating what you're doing there. And I think you have the same problem that we think of in GHOU, which is we hope and we assume the world will return to normal, and we try and work out whether we stay in the virtual environment, which allows us to speak to lots of people, or whether we go back to the kind of the local things that we used to do physically. I can see Gustavo is looking like he wants to jump in. Are you shaking your head, or are you time? Yes, I know time. Yeah, we Gustavo, we started 45 minutes late. Mila, I think we'll leave it there. But yeah, we have your contact details, which is fantastic.